Hi there. Today we're going to be working on Module 5, Lesson 2. In your Canvas course, each day we have the new notes listed, so you can look under the date Wednesday, January 29th to find the notes. What we're going to start class with is the practice test, and I try and start each new lesson with a review of what we did in the last lesson. It's a good way to make sure it's sunk in and you remember everything. And this practice test is listed under the first day of class, Monday, January 27th. So if you haven't printed that yet, you can shut off the recording and go print that. We're starting on page 2, so if you want to just print page 2 for now, but each day we'll be doing a different page. I think there's a total of course it's not turning for me. It looks like 6 pages. Yep. So we'll be doing a couple problems at the beginning of each lesson. So page 2 of the practice test, we're going to do 12, 13, 14, and 15. So since it is a review, I would like you to try these first on your own. So if you would shut off the recording and do those 4, they're from our notes from lesson 1, and then turn it back on and you can check your problems. Okay, so I'll see you in a bit. Okay, so notice that all 4 of these are translate. So we have to remember our key words: product, quotient, sum, and difference. So this is product, and we learned that when you start out with a product, it's always a good idea to put in 2 parentheses. If you have to drop one or maybe both of them, you can on the next step, but then you have them there in case they're needed. So product, and we learned that whenever there's a keyword, then you look for the word and. Whatever's in front of and goes in the first parenthesis, so I can see I'm definitely going to be able to drop that one because there's just a single term. Whatever's after the and goes in the second. Difference, so difference means subtract. There's our and again. A number and 12. So a number goes before the and, so it goes before this, and then 12 is after the and, so it goes after the subtraction sign. So when we go to write this down here, we can write it like this. We can drop the parentheses around the 2. It's a single term, but the x minus 12 still needs it. And like I said, read ALEKS carefully when you're doing your quizzes and your tests. They usually tell you which variable to use. I just use X unless I'm doing like a word problem and I need to use a letter other than that, but they always tell you use C or use D. Let C be the number. And so just be sure and use the correct letter because it will be counted wrong without that. I would give you partial credit for it if you did everything else right, but it would be nice, just read the directions and then you don't need partial credit, right? So product is times, parentheses, look for the and. Whatever's in front of the and goes in the first parenthesis. After the and, difference means subtraction. Again, keyword difference, and number goes first, 12 goes second. And then we lost the parentheses on 2, not needed since it's a single term. Number 13, twice a number. So we can do 2x, or you can put a times sign in, 2 times x. That's what twice means, 2 times something. Is less than, there's that key phrase that we learned means an inequality. Nothing can be in between any of those words. So is less than, put a less than symbol, 12. So that's a nice easy one. So twice a number, 2 times a number, is less than, and then 12. Next one, triple a number. That's the same thing as twice a number, but it's 3 times a number. So twice a number is 5 less than. Now that's not the 3 words all in a row, so this is not an inequality symbol because the 5's there. It has to be is less than with no other words or numbers to be inequality. So in this case, our is means equals because it doesn't say is less than. So is equals. 5 less than we know means minus 5 in the back. And 2/3. And this is one thing that we didn't have in our notes. I mentioned it in the video, but I didn't write it down. Of means times. So if you don't know that, put that here, because this is what you're going to use to study for your test. I use this to make the test in ALEKS. And then I would maybe even highlight it, just to remind yourself when you see of, that means times. So 2/3 of the number x. And I will tell you the biggest mistake on this one on the test is students forget the x. This means 2/3 times x. So you can't forget any of the words. The 2/3 translates to the fraction. The of translates as times. The number translates as x. So 3x equals 2/3 times x, or just 2/3 x minus 5. And the less than told us to put that at the back. And you can write it with or without the times sign. You could also write it like this in ALEKS, 2/3 x minus 5. So either way is fine. And last but not least, this one I think came right off that paper we did. The other ones, they changed it a bit. Wow, this one they give us all the room, and these they didn't. Go figure. So translate into algebra. 5 less than x. So we know that means x minus 5. Ooh, I don't think we had this exact verbiage on our sheet. Or maybe we did. Is at least. So the minute students see least, guess what they put? A less than sign. And that's wrong. And the reason why, at least means, so if I'm at least 5, I'm 5 or 6 or 7 or 8. So at least actually means greater than or equal to. Isn't that weird? It's the opposite when it says at least or at most. At most means less than or equal to. At least, so anytime I'm like fighting with myself in my head going, ooh, is that less than or greater than? I make a scenario. I am at least 20 years old. That means I'm 20 or 21 or 22 or 23. So that means greater than or equal to. And again, go down here and you can write yourself little notes, because this is going to be your guide to taking your test. At least means greater than or equal to. At most, if I'm at most 30 years old, I'm 30 or I'm 29 or I'm 28. So at most would be less than or equal to, and you do have to put the equal, because that means at most means it could be equal to 30. Equal to 30 or less. So those two are actually the opposite of what most students think, because they see the least and the most and they think less than and greater than. Just do a scenario in your head if you get stuck on that. So that again I would highlight so you have that to look at. Remind yourself. Okay, 2 more than y, so y plus 2. So there's your answer. So hopefully you guys remembered most of that from the first lesson. Okay, so like I said, make sure before the next videos to print this whole packet if you haven't already, because it's just random. I kind of just look for problems like what we did in the last lessons, and I just pick those. So the next day we might be on page 6, and then we could be on page 3. So I would make sure you have all of those so you're ready for them at the beginning of each of the videos. Or each of the lessons, I should say, not each of the videos. Okay, so this is the packet that is listed, as I said, under Wednesday 129 on Canvas. So again, if you have not printed that, I would go ahead and print it. So just stop the video. You can come back and join then when you get it printed. And we have 2 other smaller packets after this one, but most of Module 5 is going to come from this. Not most of it, but most of the pages. Okay, so we are working on simplifying algebraic expressions in this section. One second, let me plug my screen in. It looks like it's... Whoa, oh, there we go. Much brighter. So, simplifying algebraic expressions. Wow. My computer just keeps shutting off. I'm sorry. Not sure what that's all about. Okay, now I'm back. My computer just shut down. So, a term. A term is a number or a product of numbers and variables raised to powers. Whoa, is that ever wordy? So let's give a better example. So a term, if we had x plus 3 minus y. I like to think of terms as things that are separated by addition and subtraction signs. Well, let's make this y squared just so we have a power there too. So terms are things separated by addition and subtraction signs. So plus and minus. So when we were talking about on lesson 1, if it's 2 or more terms, it needs to be in parentheses. That would be 2 terms. This would be 3 terms. So there's a term, there's the plus sign. There's a term, there's the minus sign. There's a term. So this is considered 3 terms. So terms are separated by addition and subtraction signs. Numerical coefficient is the number in front of the term. So if we had 3x squared, 3 would be the coefficient. And if we had negative 5x, negative 5 would be the coefficient. So it's the number in front. See the word numerical there? So that means the number in front of each term. So here the coefficient would be 1. Here the coefficient would be 3. Here the coefficient would be negative 1. Just like this one's 3 and this one's negative 5. Like terms must have the same variable and the same power. And we're going to learn a little bit later. I think it's in example 3 on this page that if they are not like terms, I'm not allowed to add and subtract them. So it's important that you understand like terms because you need to know whether you can add or subtract them when you're combining them. And then unlike terms, oh duh, are terms that aren't like. Oh wow, that was helpful. But the key is like terms, same variables, same power. So for instance, 3x squared and negative 5x squared would be like terms. because they both have an x and they have to have the same power. They both have a power of 2. For instance, you cannot add a power of 3 to a power of 2. A power of 2 can only be added to another power of 2. So that is like terms. So first we're going to practice identifying the numerical coefficients. If you want to shut off the video and go through and answer those 6 questions, you can. Gives you good practice, lets you see where your weaknesses are so that you know what to practice on later. Okay, so the numerical coefficient for this term is -3, and yes, you do need the negative. Without it, it's incorrect. Coefficient for this term would be 22. And hopefully you all know anytime there's a variable with no number or no power, the number in front, which we call the coefficient, is 1 and the power is 1. So this one is a coefficient of 1. Likewise, -y is the same thing as -1y, so its coefficient is -1. This is the one most students miss on this. They forget that the x has a 1 in front, and they say the coefficient's 7. Well, if it was 7x, yes, the coefficient would be 7, but it's not 7x. This is the same thing as this. And that's what I tell students. Sometimes it's easier if you rewrite the problem and then you can see the answer. Oh, x over 7 is the same thing as 1/7 x. So then I can easily see that the coefficient is 1/7. So don't forget those 1s in front of variables. Any variable without a number in front of it, without a coefficient, has a coefficient of 1. And then constant terms are terms that don't have a variable. They're their own coefficient. So that is coefficients, because you have to know the vocabulary to do these. So you have to know what like terms are, what unlike terms are. You have to know what coefficients are. You're going to learn later when you go to graphing in future classes that the leading coefficient is what determines whether a parabola cups up or cups down, for instance. So you need to understand what these terms mean. So coefficient, number in front of each term. So there's a section on your test that asks for like and unlike terms. So remember what the definition says. In order to be alike, they have to have the same variable and they have to have the same power. So consider that as you're looking at these. So we're going to learn in this chapter that whenever you write an answer, your letters need to be from highest power to lowest power. And your letters are also supposed to be in alphabetical order. So this stays the same, but this would turn into 5xy. And by doing that step first, then you can easily see, do they have the same variables, x and y? Yes. Do each variable have the same powers? Yep. So these are like terms. But a lot of students won't do that step and they'll go, oh, x, y, and yx aren't the same. Oh, yes, they are. That one's just not written in alphabetical order as it should be. This one, not the same. Power of 1, power of 2. So these are unlike terms. So you would never be able to add these two. If someone said, what's 5q plus -3q squared? You'd go, just that. There's nothing I can do. If they're not like terms, I cannot add or subtract them. So C, AB squared, AB squared, A squared B. Nope, this one's not alike because this is 1A and 2 B's. This one is 1A and 2 B's. But the last one is 2 A's and 1 B. So I like to kind of, what would you call that? Expand them, and then I can look and see. These two are alike, this one is not. So here all are like terms, but all three are unlike. So I could add the first two if I wanted, 3 plus -2, and get 1ab squared, but then I would not be able to add this to them because it's not the same, because it said same letters and same exponents on each letter, and the exponents are not the same on the a's. So the three themselves are unlike, but if it was an addition problem, I would be able to add those two because they're like terms. And this is another one students miss a lot because they go, oh, that's a whole number, that's a fraction. The numbers in front have nothing whatsoever to do with like terms. This is 1y to the 5th, and this is 1/2 y to the 5th. They are absolutely like terms. They have the same variable and the same power. So you don't look at the numbers in front. The coefficients don't determine whether they're like or unlike. It's the letter and its power. Okay. So hopefully that clears up any questions you have on like and unlike terms. Huge part of this class, because we're going to be mostly solving equations throughout this class. And the first step in solving equations is combine like terms. So if you add terms that aren't alike, then you can't get your answer correct when you're solving the equation. So that leads us into this. Now we're going to be simplifying. Simplify is another word for combine like terms. So when you see simplify, it also means clear parentheses if there are any, but there aren't any parentheses here. So in this case, it just means add like terms. So I would have -3y plus 11y. Those would be like terms, but the 5's not, so it just gets tacked onto the answer. So 11 minus 3 is 8y, and then I just tack the +5 on. And like I said, when you go to write your answers should be highest power to lowest power. Constants, the number without a variable, always go last. So make sure your answers are highest power to lowest power, y to the 2nd, y to the 1st, and then constants are always last. For this one, we have 3 like terms, and they're all y squared, so I'm going to put my 1 in, and then I'm just going to go down the line. 4 plus 1 is 5y squared minus 11. So 5y squared minus 11y squared. When the signs are different, we subtract. 11 minus 5 is 6y squared, and we keep the sign of the larger negative. So when the signs are the same, we just add them. Don't touch the exponents. Exponents stay the same. And when the signs are different, +5, -11, we subtract and keep the sign of the larger. Okay, next up, this is another one students miss quite often on the test, and it's because they don't put it in the correct order. So many times Alex will say, write your answers in descending order, or write your answers in standard form. So they just do this problem from left to right and don't obey that. So we have to start with the highest power. So these two terms are alike. This one is not. So that's just going to go at the end. If it doesn't have a sign in front of it, that means it's positive. So 8 minus 3 is +5x squared, because the signs are different. So we subtract and we keep the sign of the larger. Exponents always stay the same. And then after that, we write +5x. So that's what descending powers of x mean. X to the 2nd, x to the 1st. So highest powers go first. Okay, so you guys want to try the next 5? So turn off the video, try those 5, and then come back and we'll check our answers. Okay, and make sure you put all your final answers in descending form. And if you have a calculator, which you're supposed to have for this class, this is the one I recommend. It's in the syllabus. It's about $14, $13.50 at Target and Walmart. And this is what I'll be teaching on, and this is the greatest calculator ever. And teachers allow this on pretty much every test because it doesn't do any of the fancy stuff. It doesn't do the graphing, and you can use this through your next class too. So great investment, and you're going to have problems like this. Do you want to do that in your head? Do you want to do this in your head? Well, neither one's that hard, but there's going to be some ugly stuff, so you definitely want to make sure you get a calculator. And just write this down, TI30X2S. If you get this one, it's not a good one, so be sure and write it down, because I have that one, and it's about the crappiest calculator ever. I think I used it at college, but you have to type everything in backwards. But students see these two side by side and they're like, oh, this one's $4 less money, I'm going to get this one. And it's crap. You have to type everything in backwards. It doesn't do order of operations. You can only see one operation at a time, where this one you'll be able to see the whole line. So believe me when I say the extra $4 for this one is priceless. So, and you'll be able to use it in your next couple of classes. And man, it looks like my screen is super dirty. I must have had some cream on my face, on my hands. Okay. So we'll use that in a bit, but I saw one that, and I'll show you as we go how to use it. So I would get it as soon as possible so you can follow along and make sure you know how to use it by the time it's test time. Okay, so turn off your recording, do those 5, and then come back and join me when you're done. Oops. Okay, so let's do it. So I can see y squared, like terms. So 20 plus 2 is 22, minus 1 is 21, y squared. And next we have 3 like terms here and then 2 like terms there. So we have this, and always circle the signs in front of it, because especially if you're going to be using a calculator, you want to make sure you don't miss any of the signs. So why did I circle those 3 first? Because constants always go last. So we start with x or y or whatever, and the constants go last. So this would be a good time to practice our calculator. You can probably do it in your head too. What is it, 0.7x I think, but good practice. So when you're typing it in the calculator, you just type in the numbers and their signs. So 6, and then it's going to be minus 4.3, and then minus 1. And when you're using the calculator, make sure and don't get these 2 keys mixed up. This is negative, this is subtraction, and these are subtraction signs because they're in between terms. Have we had any negative signs yet? I don't really. Oh, here's a negative sign, and there's a negative sign, because see how they're not in between numbers? So when they're in between, it's subtraction. When they're out in front of a number, then it's a negative sign. So for that negative 2/3, you'll use this. But for the subtraction problems, you'll use this. So that's the first thing I teach when I do my calculator workshop, is that these cannot be used interchangeably. You do, and you'll get an error message on your calculator. So 6 minus 4.3 minus 1 is 0.7 as predicted. So 0.7x. And then 3 plus 0.5 is 3.5. And you can do that on your calculator if you can't do it in your head. Is everybody good with that? Okay, this is another one you have to be careful with. All of your answers need to be in alphabetical order. So that means we have to start with the x's and look at the negative. Negative 3x, positive 6x. So 6x minus 3x is 3x because we keep the sign of the larger. Y doesn't have anything to go with it, and it also has no symbol in front, so that means it's plus 5y. So see how my answers are descending powers of the variable, and if there's two different variables, you do it alphabetical order. If there's a variable and a constant, constants always go last. Constants mean they don't have a variable. Opposite of variable, constant. So this would be a good one to practice on the calculator. So we have a fraction bar on this calculator. It's my favorite thing. So whenever you see a fraction bar, you're going to click this button right here, A, B over C. So first you do the negative down here, not the subtraction sign. So there's my negative. And then I do 2 fraction bar 3, and this is what it looks like when you are trying to get it out of the glare. There it is. It's out of the glare. And then now this is a subtraction. So see the difference out in front, but this is subtraction. So then you go subtract 2, and that will tell you it's negative 2 2/3. Usually we don't use mixed numbers for algebra. Another cool thing this calculator does, and this is why you want to get one right away so you can be practicing this stuff. So there's a key right here above the ABC. It says change ABC into D over E. That means change a mixed number into an improper fraction. Because it's blue, we have to use the second key and then ABC, and that'll turn it to an improper fraction for us. So this one is negative 8/3, and then you put your B on it. But you can see why I said get that calculator ASAP, because you need to practice doing this kind of stuff. Subtracting fractions, knowing the difference between negative and subtraction, and then taking that mixed number and changing it into improper. So let me go through the keystrokes one more time. So first it's a negative, and then you do 2 fraction bar 3. That's how we type fractions in, and that's what they look like. Then it's a subtraction sign because it's in between two terms. Subtract 2. The calculator's default is a mixed number, but when we're doing algebra, we don't use mixed numbers. So then we look at our calculator and say, this says fraction, mixed number, into a fraction. So second ABC, hit enter, and there's our negative 8/3. Okay, and last one, we can probably do this one without a calculator, can't we? 8.6 minus 4.3. Can I subtract those? Oh, no, I can't. So no need to even do that. Because this is power 2, this is power 1. So always be on the lookout for that, because it's easy to go, oh, 2 decimals, I got to subtract them, or type it in your calculator when you can never add or subtract these. They don't have the same power. So you would just type this in as your answer. Can't or right cannot be simplified. Alex might have a button for that. So some computers will say, if the answer cannot be simplified, just write the problem. Some will have a button that say cannot be simplified. So just follow what the directions say. Okay. Okie dokie. So we're going to stop there and I'll start the next video on page 2. See you in a bit.